Now, before we start actually putting componentry to our facade we're building, I want to create the standoffs for the glazing system. So I've made some modifications to this, the way we're looking at things, and I'll explain what I've done, and then I'll start to undo a lot of things, and we'll go back through it and build it. The last we left off, I had used a panel quad, which gives us, we put a surface in, we divide it off with UVs, we get panels and points. But the one I'd actually used was the lunchbox quad grid by face, and I'm going to use that because it generated a nice output, and I don't want to find I get downstream and have a problem. So I'm just gonna, I've deleted this one, and this is the one you should be using, which is a lunchbox functionality quad grid by face. It's really giving you the same kind of outputs, and we're getting and one of the things I've done here is I've actually turned the preview off because I'm trying to get us to be able to see this in a wireframe view. If I turn the preview back on again, and actually I'm going to turn off this other element that I've added, we can see the whole object, but we really have a hard time visualizing what's going on through it. And so what I've done just for this example, and we'll do it one more time, is I've turned the preview off of that and just turned on polygons that I've created by just taking the points of each one of those lists and making a full polygon out of it. So we get a same visualization, but we get this idea of transparency so we can see through our grid. Later on, we'll just delete that when we start to insert other componentry in. So let's go ahead and I guess I'll describe a few of the things that are going on here just as an overview. The goal here is to take this panel and have these standoffs, which might be the structure that goes back to the building to support these glazing panels, or what will become glazing panels. And you know, it's actually very easy to take a point and make a line, and you can do a line by a start point, so we could feed a point in, a direction, and a length. The problem comes in is that they're all fixed lengths and they're starting at different starting points. So we want to generate this idea of where they're ending or touching the building surface, or what would be the bottom chord of a truss or whatever it's going to be. So the idea is to actually create another surface, and I'm going to turn it on. That's a plane, which is just an extrusion of this top line. And now I'm going to turn it off, because what I've done is I've taken that plane and moved it back. And I'll turn the preview on for that. So it's now back and it's on a slider, so I can actually move this back and forth. And along with that would come a regeneration of the geometry of the lines, except those lines don't actually, they were limited in their length, so after a certain point they're no longer long enough to intersect the plane. So in this case, now you can see what's happening as I draw that panel surface closer to the wall, those lines get shorter or longer and shorter. So I'll just pick up a number that works here, that doesn't error us out. That gives us, let's try 8. I think we still have some missing here. We'll go to 7. So that's like a 7-foot standoff. Pretty deep. Let's try to go, and the idea here is we're balancing between the depth of that face, and let's say we did 3, and let's see what happens, see if we get any intersections of our, alright, so in some cases we've got our facade buried into that. That's actually going to disappear later on as we get to having a finer resolution probably to that. So let's try 4. And I'm just going to turn off this surface now so we can see if all of our standoffs are there, and it appears they are. And so I just take that surface and intersect it and then make a new line with it, which is what we're seeing there. So let's go ahead. I'm going to delete all of these, delete all these elements, and we'll go through and actually construct this component or set of components. So I'll work back to where we This would be where we would have left off except for the substitution of the grid box. And I'll put that in preview so you can see it. And then I'm going to go ahead and turn that off right away. And I'm going to take these poly points now and look at getting them into a view that we can preview them. And we're going to do that by polygon by points. Or polygon by corners. Nope, input. I'm going to have to do the whole thing, I guess. There it is. Okay, so we'll just plug the points in. And now we have that visualization of it. Now the idea is that right away what we want to do is we want to create a line. And so let's do a line by a start point and a direction and a length. Start point, end point, but we want a direction and a length. Let me just type a little more in and it might just scroll down for us. Start point, it's just a straight line, extending vector in a direction, a specified length. All right, so there we are. So we're going to take that start point and put it in here. And we need a vector. We need a direction to move that out. And I'll put that in without giving a direction to that vector, and then we'll give this a number for its length. And I think I used 10 feet just to make sure it was long enough. I'll plug that into the length. And it looks like we're not happy with having a vector with no values in it, no direction. So I'm going to make another number. And we'll put a 1 in, that's just to move it in a direction. And we'll figure out which way it needs to go. I just happen to have that right. We can go experiment what happens when you screw around with this. All right, so we really wanted in the X, or in the Y direction, excuse me. So there we have our lines right away. You know, the power of working with list. We have all of the 4 points coming out of each one fed into here. And we have now a line drawn from those points correspondingly from that point in the Y direction for a length of 10 feet. Now, like I said, these are all going to be different lengths, and I guess I need to rotate this view around so that you can get a better idea of what's going on here. I guess what I really want to do is just show you how these are all different lengths by nature of where they're starting from. And that's a problem when we want to try to align it to a planar surface, which might be the floors, interior of the building, or trusses. So our way to solve that problem then is to intersect it with another plane. And in this case, an easy way to go about that, or a quick way to go about that idea, would be to take the line that's at top of our facade line and then extrude it down to make a surface, and then move that surface back to represent our wall surface. So I'm going to go and look for a curve extrude, and that line, even though it's a straight line, it's still called a curve. So we'll do extrude. All right, and it's asking for, I want curve extrude at a distance, in a direction. I want both. There you go. So this line already exists over here. If I select this, you'll see that's that top line. So I'm going to go ahead and use that line and feed it into the curve. and we get, it always usually defaults to 1 in some vector distance. So we have a default of 1 foot and a direction of XY in the Z plane. So we need to alter its distance. So let's work with the facade height as the distance. And we'll plug that in here. And that's going in the wrong direction, so we need a vector. So I'm going to grab this vector up here that we've already created. And we really want to go this time in the Z direction, like we're going. But it actually will allow us to put a negative here to give it a direction. So I'm going to do a -1. Put our direction vector in. And now we're all the way through from top to bottom and all in perfect alignment with the facade we've created. So our problem now is just to take this and move that back, actually to get it to represent the face of the building, or as I said, bottom chords of the truss. So there's a translate geometry. Let's see if I can find it. Translate geometry that allows us to go ahead and move that. So I'm going to plug that surface into here, and then I'm going to just do, I'll use a number instead of a slider this time. And we'll give this a value. Maybe we said 4 before, I forget. And we're going to move that, what turns out to be the Y direction, same way we're moving these standoffs. So if I plug that in there, we get the other plane. So now we have that intersection one. We still have the original curve showing, so I'm going to go ahead and turn that off so we can see the surface going through. And I'll just take a minute to maybe rotate this so it might be clear for anyone that wants to look at it. Alright, so now we have our curvy geometry flipping back and forth, and we have our lines and then the potential to determine an intersection between this line and this plane. So in order to do that, we have to look at, oops, my reference document, which you can't see on another screen. We're going to use the term geometry intersect, because we're going to take the lines and we're going to intersect it with that surface. So I think if I type in intersect, no, I probably should have just said geometry intersect. Well, I had to type everything. All right, so the idea here is we have a geometry that we want and something that it intersects with. So this is the plane that we have grabbed, and these are the lines we have made. And if we put those two together, what's going to end up coming out are an intersection, which is a list of points. So each one of these, and let me just zoom in here so you can see what's going on. So this is the geometry of the wall intersecting with the geometry of the lines. If I highlight the lines, you can see that go blue. If I highlight this, you can see the wall go blue. So the intersect is points, which it automatically takes a line, intersects it with a surface, and the resultant turns out to be a point. So we come up with a series of points. So now we can go ahead and go back here and start turning these elements off. So I'm going to turn the preview off for the original lines. I'm going to turn the preview off for the geometry that we're intersecting with. And we now have a start and end point for each one of the panel points. So now we want to recreate actually another line. And we have already started that the first time, where we gave it a line by a start point, a direction, and a length. But now we're going to use another similar tool, and that's a line with a start point and an end point. So we have our start point, which is the panel points themselves, and our end point, which are the endpoints that we've found from intersecting. And there we have it. So now we have our what can be constructed into standoffs or truss elements on our facade. And now we can upscale the amount of resolution in this as we get further along in development. But we'll end this right now, and then I'll pick up with actually adding some thickness to these components in the next clip.